Today we are comparing two types of bearings, a healthy bearing and a flat bearing. On the left, we have a healthy bearing. Notice its smooth round surface and the lack of visible wear or damage. A healthy bearing operates quietly with minimal friction and vibration. Proper lubrication ensures it runs efficiently and has a long lifespan, providing optimal performance in industrial machinery. Now on the right, we see a flat bearing. This bearing has clear signs of wear, including flattened spots and scratches on the surface. Due to increased friction and damage, a flat bearing generates excessive heat and noise, leading to higher vibration and a much shorter operational lifespan. Without immediate replacement, a flat bearing risks causing further damage to machinery. In this comparison, we explore the difference between a healthy bearing and a flat bearing, focusing on potential causes and how they manifest in waveforms and frequency charts. First, let's look at a healthy bearing. A healthy bearing operates smoothly with low friction and minimal vibration. The time domain vibration waveform of a healthy bearing is consistent, with low amplitude variations. In the frequency spectrum, the bearing's operational frequencies appear normal, with no unusual peaks. Now let's examine the flat bearing, which shows visible signs of wear and damage. Flat bearings are caused by various factors, including insufficient lubrication, overloading, misalignment, contamination, vibration, shock loads, electrical erosion, and fatigue. When a flat bearing operates, its worn surfaces cause spikes in the time domain vibration waveform, creating irregular and high amplitude impacts. These impacts occur when the rolling elements pass over the flattened or damaged areas of the bearing. In the frequency spectrum, we observe peaks in characteristic defect frequencies, such as the ball pass frequency of the outer race, inner race, and the ball spin frequency. These frequencies reveal the precise location and severity of the damage. In summary, while a healthy bearing ensures smooth, efficient operation, a flat bearing introduces noise, vibration, and heat, leading to a reduced operational lifespan and eventual machine failure. Monitoring vibration waveforms and frequency spectrums is critical for early detection of bearing faults. In this chapter, we will delve into the differences in vibration analysis charts for frequency and waveforms between a flat bearing and a healthy bearing. By examining these charts, we can identify key indicators that differentiate the performance and condition of the bearings. This analysis is crucial for predictive maintenance and ensuring the longevity of machinery. Let's start by looking at the vibration analysis chart of a healthy bearing. Notice the consistent and smooth waveform with minimal peaks and troughs. This indicates stable operation with negligible noise and vibration. Now compare this to the vibration analysis chart of a flat bearing. You'll see irregular and pronounced peaks reflecting increased vibration and noise levels. These anomalies are telltale signs of bearing wear and potential failure. By regularly monitoring these charts, maintenance teams can spot early signs of bearing issues and take proactive measures to prevent costly downtime and extend the lifespan of machinery. Understanding these differences and acting on them is key to effective predictive maintenance. This not only saves on repair costs, but also ensures smooth and efficient operation of equipment. Stay tuned as we continue to explore more aspects of bearing maintenance and machinery health in our upcoming videos.